This video covers section 3.1, part 1, review, verifying identities. When verifying identities, we typically start off with the left side and try to make it equal to the right side. You can start with the right side and make it equal to the left side, but the way these are typically set up is the left side is the one that's easier to manipulate. So starting with the left side, we start off with secant x minus cosine x. It's always a good idea to write them back into sines and cosines and see what you have. We have the subtraction of two expressions, so let's get a common denominator of cosine x. So we'll multiply this one top and bottom by cosine x. And now that we have a common denominator, we can go ahead and subtract across the numerator. Now 1 minus cosine squared, if sine squared plus cosine squared x equals 1, then 1 minus cosine squared x equals sine squared. So I get to that part right there and I look back and I say, well, that's what I want to have, so I got to somehow manipulate this. I'll take one of those sine x's and put it over the cosine, and then I'll be left with one more sine x, giving me sine x over cosine x is tangent times sine x. And we've got where we wanted to go. So it's just verifying it. We verified it, so we're done. The next one, the left side certainly has a lot more that we can do to it than the right side. Just a secant x on the right. So like I said before, let's write these all in terms of sines and cosines. All right, so the most obvious thing to do would be to write sine squared there. Divided by cosine x. And so then as before, when you see the plus sign and we see it needs to be a single term on the right, let's get a common denominator. So we'll multiply cosine x top and bottom by cosine. And we have cosine squared over cosine x then. Now the numerator we can add, numerators we can add because their common denominator is cosine x. And so you should start to see this take shape. We want it to be secant x. The numerator is cosine squared plus sine squared. That's 1 over cosine x. And 1 over cosine x is secant x. So we've just verified that that equals secant x. And the next one, sine squared theta times 1 plus cotangent squared theta equals 1. When you see things like cotangent squared or tangent squared, you have to remember that the trig identity, sine squared plus cosine squared equals 1, gives us two identities in cotangent squared and tangent squared. And so to get a cotan squared, I would want to divide everything by sine squared. And so that tells me that 1 plus cosine squared over sine squared is cotan squared, and 1 over sine squared is cosecant squared. So that tells me that that 1 plus cotangent squared is cosecant squared. Now we know we want to be equal to 1, so somehow this has to be equal to 1. And the way to see that is the cosecant squared is the reciprocal of sine squared. And anytime you multiply an expression by its reciprocal, you get 1. So that identity has been verified. The next one, secant theta minus 1 times secant theta plus 1 equals tan squared theta. The most obvious thing to do is going to be to FOIL these two binomials out. Secant theta times secant theta is secant squared theta. Secant theta times 1 is secant theta. -1 times secant theta is negative secant theta. These are gone, cancel. -1 times 1 is -1, and we have secant squared theta minus 1. All right. So when you see secant squared theta, just like I was talking about a bit ago with the cotan squared theta, there's an identity for that one as well. If 1 plus cotangent squared is cosecant squared, then tan squared plus 1 equals secant squared theta. So from that identity, if you subtract 1 from both sides, that says secant squared theta minus 1 is tan squared theta. So we've just verified that identity. One minus tan x divided by sine x, and we want that to be cosecant minus secant. So there's a few things we could do here, but I think one of the most basic things we could do is just split this up, because I'm seeing that they want that to be cosecant for the first term. And if I split this up as 1 over sine x minus tan x divided by sine x, at least I see it right there. That's cosecant x. Now that says then that tan x over sine x should be secant x. If it's not, then we either made a mistake or we have to start over again. Tan x is sine x over cosine x. And then if you divide that all by sine x, that's 1 over sine x. That just gives us 1 over cosine x, which is secant x. So that one works out pretty easily. One over sine t minus 1 plus 1 over sine t plus 1. All right, common denominator in that one is sine t minus 1 times sine t plus 1. So this one's going to have a sine t plus 1, and this is going to have a sine t minus 1. Now, when you FOIL out the sine t minus 1 times the sine t plus 1, you're going to be left with sine squared t minus 1. Adding those together, you have 2 sine t in the numerator. So we see the 2's taking shape. Where's the negative come from and the tangent is secant? Well, sine squared plus cosine squared equals 1. And so if I do sine squared minus 1, that'll actually equal negative cosine squared t. So this gives me -2 sine t over cosine t is the tangent we're looking for. And then we have 1 over another one of the cosines, which is where the secant comes from. And so that one's been verified. This concludes section 2.4, part 1 review. I'll do the rest of these identities in the part 2 for section 3.1. This is what this one is. Section 3.1, Part 1 review.